As you saw in the last few videos, it's kind of hard to work with dates without thinking about your location. This is the essence of localization. Where you are matters because where you are or the region you're from determines how you'll expect to see dates, currencies, and numbers formatted. Even ignoring language differences, these formats can be different for different cultures and locations. For example, Australia displays dates differently than the United States, though both countries are primarily English-speaking. As another example, many countries use different currency symbols and have different scales for the least significant currency digit. Locale is an English word for a place where something happens. It's also the name of a class in the java.util package that underpins support for both localization and internationalization. Java has some built-in support for localization with methods that let you pass a locale instance to them. A locale has 5 fields: a language, a country or region, a variant, and less apparent, are script and extensions. Underneath the covers, most of the fields are on a base locale class, as shown on this slide. You really don't need to know this structure, but I display it here for accuracy. Java provides localization support for dates, numbers, and currencies with no additional effort, other than defining a locale and passing it to certain methods. For language constructs, other than a month or a weekday specified in a date, you'll need to do some additional work, and I'll talk about that later. In this video, I'll be covering the built-in support. Internationalization, or I18N for short, is a method of designing your application to allow language and regional elements, with the help of locales, to be plug and play. Strings used in messages or user interface elements and images are stored externally to the application. These can be retrieved using a locale and then displayed for a specific user. Java uses the resource bundle class to support this feature, and I'll cover that a bit later. I've created a new project and called it Locale Project. I want to start by talking about the default locale, which you can get by calling the static method getDefault on the locale class. Running this code, you should get a code back, usually made up of a 2-character language code, an underscore, and a 2-digit country code. You can see mine is EN_AU. I can change the default locale by calling setDefault. I'll do this before that first statement. I'll use locale.us, which is a static constant on the locale class, and I will pass that to the setDefault method. Running this code, you can see I get EN_US now, so EN is the language code for English, and US is the country code for the United States. There are a few of these constants on locale. I'm going to view the structure of this class in IntelliJ. First, I'll double-click on the class name locale so that it comes up in a tab in IntelliJ. Then I'll open the structure window. I'll scroll to the top of this window. The nested types on this class are displayed first. These are followed by the methods on the class, and if I keep scrolling, you'll see F for fields. Here I want you to notice the static fields on this class for a small subset of valid locales. The first few are just for language: English, French, German, and so on. At a minimum, a locale needs a language. After this, there are country locales: France, Germany, Italy, etc. For these countries, they only have one language. So when I used locale.us, I got the locale that had English as the language and US as the country or region code. Although these locales don't tell me what the languages are, that field will be populated for each of these. Notice the 2 entries for Canada. The first has no language specified in its name. That field in this case is EN, or English. Canada also has French-speaking regions, and that locale is also supplied here as well, Canada_French. I'll minimize this pane for now. Getting back to the main method, I want to show you how to create locale instances. There are multiple ways to do it. For the majority of locales, you'll only need the language and country codes. On this slide, I'm showing you a useful link, which displays all of the JDK 17 supported locales. I'll open that link and scroll to the top of this table. This table lists the languages first and then the countries within that. The script is basically the alphabet used, and the language tag is similar to what gets printed by default, but has a dash instead of an underscore in this table. You can create a locale if you know this language tag, and I'll show that to you as well. I'm not going to be covering variants, but they can be used to define known variations of a language or its dialects. I'll scroll down until I get to the English language. Here you can see the countries that have English as one of their languages. Australia is first, then Canada and India and so on. The language code is listed after the language, and you can see EN there. Language codes are lowercase. The country code is listed after the country name, and you can see Australia is AU and Canada is CA. I will get back to the code and create a few locales. At a minimum, all you need is a language code for a locale constructor. The locale class doesn't have a noargs constructor. I'll create a new locale using EN as the argument. This locale doesn't have any country associated with it. You can do this, but it's much more common to include a country. I will do that next, creating two local variables both using the English language. The first Australia, AU is the country code for Australia, and the next CA for Canada. I can also create a new locale using what's called a locale builder. Builder is a nested static class on locale, and here I'll create a new instance of this nested class. I'll chain a call to set language, passing EN, and chain a call to set region, passing IN, and finish with a chained call to the build method that returns a new locale instance. I'm going to copy that last statement and paste a copy right below. I'll change the name of the variable to ENNZ for New Zealand, and I'll change the set region call, passing that NZ instead of IN. I'm going to use each of these locales to print a date. I'll first set up a date-time formatter variable. I'll use the medium format style, which you saw me use in a previous video. I'll use an enhanced for loop to loop through these locales I created. I'll create a list on the fly. I'll pass in the default locale.us, the EN variable, the ENAU and ENCA variables, the locale.uk field, and the last two locale variables ENNZ and ENIN. I'll print the display name for each. Then I'll format the local datetime instance I get back from calling now. I can pass the format method a datetime formatter instance, and here I'll pass the DTF variable. Notice though that I'm actually not passing the DTF variable, but a new instance of a datetime formatter that I get back from the call to the withLocale method, passing my loop variable. If I run this code, my current date is printed out for each locale I specified. The first was the default locale, which I made English and the US. The next one is the same, though it's my local variable locale for that language country combination. The third one is what I get for just an English language locale. You'll notice this looks just like the ENUS date. Next I've got Australia, Canada, UK, New Zealand and India. If you look closely at these, you'll see that for 6 countries, all English speaking, there are 6 different formats for the localised date time using the medium format style. Some use the AM/PM specifier, others use a 24-hour number, all but one use July, but some have day first, and some have day following the month, and so on. I hope this points out the importance of a locale, just for date formatting. You can imagine as we expand the locales to other languages and countries, how many different ways the same date could be displayed. I'll be showing you an example of this in the next video, before this video gets too long, so I'll see you in that video.